This is the root of a winter bean drilled in quite difficult conditions in January. We've already found a huge amount of worms within the soil structure, but what we're looking for is the nodules of the nitrogen. This is where the plant creates residual nitrogen for the soil through rhizobial activity. Are used to getting quite small, sort of pinhead type. Often when we cut open them, they're not red. But what we're seeing now is we've started to build a nutrition package to try and build soil health and soil function. Two of the limiting factors we have in our soil are calcium and molybdenum. And molybdenum helps create the enzyme pathway to synthesize nitrogen from the atmosphere. What we're starting to see is much bigger nodules. If you cut the nodules open, they want to be dark red. It's called leg hemoglobin. And typically when we cut a nodule in half, they were often white in colour. But what we're starting to see is much better rhizobial action and the formation of nodules on the roots. From the few soil pits we've dug so far today, we're seeing a huge amount of worms, which is really pleasing because we had to cultivate in quite wet conditions and I was worried about sort of harming the soil ecosystem. And we're starting to see lovely formation of nodules on the roots. There's a range of colours from I guess younger ones being formed to mature ones, which are probably about to be ingested into the soil microbiology and release that nitrogen back to the soil. Certainly that's what will happen after combining and cultivation. Through balancing the soil and working with the soil analysis, that we're starting to remove limiting factors in the soil and balance the soil's requirements rather than just prescriptively going on with a synthetic traditional agronomy approach. As part of this sort of analysis process, we've run an NVDI camera across the whole crop. Those that understand the NVDI interpretation better than me are seeing better photosynthetic capacity where the Sea2Soil product was used across this side of the field. Primarily, we're using the Sea2Soil product to build biology, to build nitrogen. What we are starting to see with the Sea2Soil is it seems to be supporting clover and other leguminous crops like this. This is a bean and triticale crop. The triticale is very poor, but the beans are looking superb. We have a bean and wheat crop over there, and there isn't much of a comparison, but in the spring pea barley crop, we're definitely seeing greater biomass. So we're using the Sea2Soil to start helping support the biology, to build a better nitrogen cycle within the plant, and to hopefully push protein production within the organic farming system that we're operating. Because we run a mixed farm, we've got a good level of soil biology, but we've highlighted that the soil needed calcium, needed molybdenum in the first instance. So over the sort of 4 core areas within the field we want to sample, I want to see that the calcium product that we applied worked, and the molybdenum will either see better microbial biomass, slightly higher levels of molybdenum. This field is running at about 1/10 of the molybdenum required. And it's a tiny application amount. I think we put 100 grams a hectare on of molybdenum, but we're going to do this over 2 or 3 feeds to try and just get this function. So we're hoping that the soil analysis will show higher, potentially mineralizable nitrogen, a better balance of calcium, and the fact that we're starting to affect increases in molybdenum.